Stoichiometry is the determination of the proportions in which elements or compounds react with one another. The rules followed in the determination of stoichiometric relationships are based on the laws of conservation of mass, which state that matter is neither created nor destroyed. The limiting reactant in stoichiometry is the substance that prevents more of the product from being made. For example, to make a full car, it would take 4 wheels for each body. If we were to have 4 car bodies and 12 wheels, we would only have enough tires to make 3 cars and have 1 car body left, which would mean that the wheels are preventing more cars from being made, which makes it the limiting reactant. In this lab, we will observe the double displacement reaction between copper-2 sulfate and potassium hydroxide in different ratios. We will collect a series of data on the precipitate, and the precipitate is a solid formed from the 2 mixtures, and the supernatant is a liquid lying above a solid residue after crystallization, precipitation, centrifugation, or other processes. The materials given in this lab are some stirring rods, 2 burettes, 8 test tubes, distilled water, copper-2 sulfate, potassium hydroxide, and a graduating cylinder. We started our lab by rinsing our equipment with a regular sink water and then distilled water to make sure there would be no cross-contamination with the last experiments done last period. Some observations that we found is we observed that copper-2 sulfate was like a blue-like color and potassium hydroxide was more clear.
The setup for this lab was pretty simple. We had to fill one beer with 0.2 moles per liter of potassium hydroxide and the other with 0.1 moles per liter of copper-2 sulfate. We were given 8 test tubes and we had to dispense 5 milliliters of copper-2 sulfate into each test tube, and we added 1 milliliter of potassium hydroxide to test tube 1, then by increasing amounts to all the rest of the test tubes. Then we had to make each test tube 13 milliliters of solution, so we had to add distilled water to each test tube to achieve that 13 milliliters. After this lab setup, we had to mix and start the chemical reaction. We took the stir stick and mixed it for about 1.5 minutes, and then we let it sit so we could measure the precipitate height at the right levels. The test tubes 1 through 4 had a light blue solution, and it was light and cloudy with the light white little dots inside of the tube. It was different in test tubes 5 through 8, and the precipitate was turquoise blue, dark while mixing, and it had flakes of dark green floating inside the precipitate going towards the bottom. We let the test tube sit for 15 minutes to settle all the precipitate at the bottom. Once it settled, in test tubes 1 through 4, it was really low and light blue and whitish at the bottom, but it had a gradual increase, and in test tubes 5 through 8, it had a dark blue precipitate and it rose dramatically at 5, but then leveled off and stayed consistent with the height and amount of precipitate.
In test tubes 1 through 4, the precipitate seems to have a trend. The trend is that the precipitate is rising and getting higher measurements, and this is because as you increase the amount of potassium hydroxide and mix all the test tubes with the same amount of copper-2 sulfate, the potassium hydroxide is getting all used up within the reaction. This means that the limiting reactions in test tubes 1 through 4 is also the potassium hydroxide, and it controls the amount of precipitate being produced.